Well, students, in this part of the section, we are going to differentiate between conductors and insulators. Well, all of us know metals like copper, aluminum, and silver are called conductors, where copper, aluminum, and silver have free number of electrons, or you can call it as mobile charges for conduction. Hence, said, conductors can conduct electricity easily. Substances like glass, lucite, and wood are called insulators. Glass, lucite, and dry wood are known as insulators because they do not conduct electricity. Reason is conductors have a large number of free electrons that are easily movable on their surfaces, and hence they are available for conduction. Whereas insulators do not have a large number of free electrons which can move on their surface. Hence, insulators cannot conduct. In the preparation of electric wires, copper wire is being used as a good conductor, and as a protective layer, an insulating material such as rubber is being used to cover these conducting materials. All of you must have seen these wires at home as well as anywhere around. If a conductor is taken, or a material such as gold ball or any other good conductor is taken and is now placed in contact with a body which has excess charges, all the charges tend to move on the surface of that conductor, which means this conductor allows the spread of charges throughout the surface. Hence, it is showing that charges can easily move on the surface of a conductor. Similarly, if I now consider a plastic ball and take a body which has excess charges and bring it in contact with it, the charges do not move throughout the surface as it happened inside a conductor. But in this case, all the charges accumulate at one surface without spreading on the surface. Hence, an insulator does not allow the free movement of charges on its surface. Hence, insulators do not conduct electricity. Now, how do these objects become positively charged, or how do they become negatively charged? Let us consider I have got an conductor which is right now neutral. There are equal number of positive charges as well as negative charges. Such type of bodies are known as neutral bodies. Now, if the electrons from such type of material have been removed, then the conductor becomes positively charged. So let us say that I've got a neutral atom right now. And when I say a neutral atom, it means the number of positive charges is equal to the number of negative charges, or the number of protons is equal to the number of electrons. If I somehow remove an electron from its orbit, what happens is the number of protons become greater to the number of electrons, resulting in deficiency of negative charges. Hence, we can now say by removing that electron from there, we have converted this neutral body into a positively charged body. Similarly, if suppose I have a body which is neutral, and if I add some extra electrons to it, this body should now become negatively charged. That is, if I again consider a neutral atom where the number of electrons is equal to the number of protons, and if I somehow if I somehow add an electron into its orbit in such a way that the number of electrons in that atom become greater than the number of protons in that atom, then we can say the body has acquired more negative charges. Hence, this body now gets converted into a negatively charged body. Hence, we come to a conclusion saying electrons do not